Kia ora. What are logarithms? Logarithms were invented by a man called John Napier, who was a Scottish mathematician, and I think it was around 1550. The reason he invented them was back before we had calculators. It was really difficult to do difficult multiplication and division. So the essence of logarithms is they made those problems doable. And when we look at the log properties, we'll discover that you can effectively change division and multiplication into addition and subtraction problems. So there were books called log tables, which people older than me did actually use at school. Nowadays, of course, we use our calculators. They do also have wider applications. So firstly, we'll just be looking at the basics of changing something to log form. We do know in our calculator that we've got this LOG button and this LN button, and we will be going into those in more depth. At this stage, we'll just focus on the definition of logs, really. So, defining a logarithm. Example, the log of 81 in base 3 is equal to the power that 3 must be raised to equal 81. Have a think about what that would be. So the log of 81 in base 3 would be 4 because 3 to the power of 4 is equal to 81. The log of 1000 in base 10 is equal to the log that 10 must be raised to equal 1000. What would that be? So the log of 1000 in base 10 would be 3 because 10 cubed is equal to 1000. So the log of a number in base b is equal to the power that the base b must be raised to equal the number, which sounds quite complicated. The log of 32 in base 2 is equal to 5. And that's because 2 to the power of 5 equals 32. So the way we can write this in general terms is that log of n to the base of b is equal to x in log form. We can convert that to index form by saying that b to the power of x is equal to n. So you've got log form and index form. And on our formula sheets, we have this formula. So we have this ability to be able to convert from log to index form. So I've just put here, remember, logarithm, index, power, exponent are all names for the same thing. So if you see that in a book, just be aware of that. Just identifying, so the log is the x value, the number is the n value, and the base is the b value. Here's a couple of examples. So rearranging a logarithmic statement, here we go. First one, we've got write 64 is equal to 4 cubed in log form. So I would be looking at the formula on this PowerPoint or on your formula sheet, and I would just be assigning the various letters. So obviously it's an index form. To change that, what is the b value that we can identify, the n and the x value, and then just substituting them in. So we should find there it's log 64 to the base 4 is equal to 3. Next one, log of 125 to the base 5 equals 3. So in index form, that will look like, just again doing the same thing, 5 to the power of 3 equals 125. Final one there, evaluate log 243 to the base 3. In this situation, what we want to do is to understand the question. So we've got, if we actually looked at through multiples of 3, 3 times 3 times 3 times 3 times 3 equals 243. So therefore, log of 243 to the base of 3 must be equal to 5. So this is a wee introduction, and we will be recapping this in our next lesson. But what I want you to do is to go to page 286, exercise 19.01, and I've put there just to try every question, and every second letter within that should be just a good start. So see how you go on that, and good luck.